Now we're going to do some examples with the genes that are located on the sex chromosomes. If we remember that humans have 23 pairs of chromosomes, chromosomes 1 through 22 are called the autosomes, and chromosome pair 23rd pair are the sex chromosomes. And as stated, they determine the sex of the offspring. For females, we use the alleles big X to represent the genotype of an offspring that is a female. For males, we use the genotype big XY as their genotype. The reason is, if you look on the slide in the PowerPoint, you can see that a female has two full-size chromosomes, two full-size X chromosomes, versus the male only has one full size of the X chromosome and just a short piece of the second chromosome denoted as Y. So in sex chromosomes, you have to show the genotype both of the trait that you are going to follow and the genotype of whether it's a male or a female. If we look at the example that we're going to do in class, which is color blindness is carried on the sex chromosomes, and let's use a B and little b to represent the trait. And so for a female, you can have a female that is not colorblind, you can have a female that's not colorblind, but she can pass on the trait to her offspring. And we call that female a carrier. The third possibility, which is more rare, is a female that's actually colorblind. And it's more rare than a male colorblind person because the female has to get the two recessive traits to have the condition. For the male, we're only going to look at the X chromosome to see whether or not they have color blindness or not. The Y chromosome does carry a small amount of genes, but for color blindness, it doesn't carry the second allele. So for male, you have two possibilities. You can have a male that has normal vision, it's not colorblind, or you can have a male that is colorblind. A lot of people contribute that sex-linked traits usually get passed down from the mother to the sons because the sons only need one allele to exhibit the trait. Okay, so let's do our example. Our example in the PowerPoint says to cross a carrier with normal site. And remember that I'm always going to give you the mother first, just so that we're doing it the same way and it's easier for us to do our work and talk about it. And so when you start out, remember step one is give the genotypes of the parents. So I always start out with sex-linked traits by putting the genotypes for whether they're a boy or a girl, because I know that's going to be required for a sex-linked trait. Then I figure out what the alleles are going to be. And so she's a carrier, so that means she doesn't have color blindness, but she can pass it on to her children. And the male is normal sight, which means he has a big B since color blindness is carried in the recessive form. So that's step one. Step two is to complete the Punnett square. So we put the mom on the side. Again, we have to use the X's and the Y's because they are part of determining how this trait is passed along. And so for this possible offspring, the mother's going to contribute X big B across. Then here she's going to contribute one X little b and one X little b. Then for the father, he's going to contribute an X big B, an X big B, and a Y. So right off, there's a 50% chance that they're going to have a boy versus a girl. Now, this third step of your Punnett square problems is to write all the possible genotypes. So I'm going to start here in this square, and I know that I have X big B, X big B, and I look and see if any others in my Punnett square are the same, and they're not, so I'm going to put a 1 there. And then I'm going to go down to the next square. I have X big B, X little b. Again, it's just good habit to put the big letter first since it's dominant. I'm going to look see if I have any that match it, and I don't, so I have 1 that's that genotype. Then I'm going to look at this square. I have X big B Y, and I only have 1 of those. And then I look at this square, and I have 1 XB little b Y. The next step of your Punnett square is to determine the phenotypes of the offspring. So here I have 1 female carrier. Remember, female and male is a phenotype. I have 1, sorry, she's not a carrier. I was trying to go too fast. 1 normal vision. With 1 female carrier. I have 1 male normal. And I have 1 male that's colorblind. So you could be asked several different questions. You could say, from this cross, is it possible that these 2 parents have a child that has color blindness? So first you just look at your phenotypes and see what are the possibilities of being colorblind. And so it's 1 out of 4. So they have a 1/4 chance of having a child that's colorblind, or 25%. You could also ask, what is the chance of this cross of parents not having a child that's colorblind? So here's 1 that's not colorblind, here's 2 that's not colorblind, here's 3 that's not colorblind. So 3 out of 4 possible offspring would not be colorblind.